exam is how do we measure angles formed by intersecting chords. So let's first review what we've learned so far about angles formed inside a circle. Okay, so there are two things that we learned. We learned that an inscribed angle, namely angle ABC, ABC is an inscribed angle. Why? Because its vertex is on the circle. Notice how angle B has a vertex that's on the circle. What is the intercepted arc? Well, the intercepted arc is none other than this arc right over here, arc AC. And one of the things we learned is that an inscribed angle is equal to 1/2 the measure of its intercepted arc. So measure of angle B, for example, is 1/2 the measure of arc AC. So measure of angle B is equal to 1/2 the measure of arc AC. So for example, suppose AC was 60 degrees. That means that angle B, which is an inscribed angle and which intercepts arc AC, is equal to 30 degrees. We also learned that a central angle, which is an angle whose vertex is in the center of the circle, is equal in measure to its intercepted arc. So for example, if the measure of arc, let's do this in another color, the measure of arc AB here in red, if this arc was, let's say, 85 degrees, that means that the measure of angle AOB, the central angle, is also equal to 85 degrees. But what we want to figure out is what happens if you have two intersecting chords and they create an angle not on the circle but inside the circle. So for example, I have chord AB and CD that intersect, and the question is what relationship do the arcs have, these intercepted arcs have, with the angles that they create, namely angles 1 and 2. So this is nothing like anything we've ever seen before, but let's go back to something we've learned in the past. And what we're going to do is we're going to look at a couple of theorems that we've learned and we're going to apply them. The first one is called the external angle or exterior angle theorem. And the exterior angle theorem says that an exterior angle, which is this angle right over here in a triangle, is equal to the sum of the two opposite interior angles, two opposite or two remote interior angles. So in other words, angle 1 is equal to 55 plus 60, which is equal to 115 degrees. So the measure of angle 1 is equal to 115 degrees. It's called the exterior angle theorem. Okay, so you're wondering to yourself, well, what does this have to do with circles? Triangles, circles, where's the intersection of those two things? No pun intended. So here's what we're going to do. I'm going to use the inscribed angle theorem, which is the one we just reviewed before, that an inscribed angle is equal to 1/2 the measure of its intercepted arc. And I'm also going to use the exterior angle theorem and a little drawing, and we're going to show what relationship does angle 1 have with arc DB and arc AC, because there is a relationship. First thing I'm going to do is I'm going to draw a line. I'm going to draw two more chords. Just when you thought there were enough chords, I'm going to draw more chords. And one chord is going to join A to D, and the other chord is going to join C to B. There we go. And maybe what we'll do is maybe we'll make these dashed lines just for kicks, just to make it look different. There we go. Okay, so what have I created? Well, let's take a look at the arcs that are intercepted by these two angles, namely angle A and angle C. Notice how angle A and angle C both intercept arc DB. So angle A intercepts arc DB. Notice how the two chords, namely AD and AB, when extended all the way, end at these endpoints, endpoint D and endpoint B. And therefore angle A intercepts arc DB, and angle C also intercepts arc DB. So we know that angle A and angle C are equal to each other. That's really not what I'm interested in. All I want to say is that I know that angle A is equal to 1/2 the measure of arc DB. So I'm going to write that. So I'm going to say that angle A is equal to 1/2 of measure of arc DB. We know that because an inscribed angle is equal to 1/2 the measure of its intercepted arc. We reviewed that right over here. An inscribed angle is equal to 1/2 the measure of its intercepted arc. Okay, now I'm also going to look at angle D. Okay, so angle D is this angle right over here. And I'm going to use two little hash marks to denote angle D. And angle D has a relationship with its intercepted arc, namely intercepted arc AC. What do I know about the measure of angle D, this inscribed angle with its intercepted arc? I know that angle D is equal to 1/2 the measure of its intercepted arc, which is arc AC. These two pieces of information are going to be important, are going to play a role in the relationship that this angle, angle 1 and angle 2, have with its intercepted arcs. And the role it's going to play is as follows. Let's go back to the exterior angle theorem, which is this. An exterior angle is equal to the sum of the two remote or opposite interior angles. Let's keep that in mind. That means that angle 2 is equal to the sum of angle A plus angle D, right? Angle 2, this angle over here, is equal to the sum of angle A plus angle D. So that is equal to angle A plus angle D. An exterior angle is equal to the sum of the two opposite interior angles. Here's one opposite angle, here's the other opposite angle. Angle 2 is equal to the sum of these two opposite interior angles. Well, wait a second. Angle A, we already know there's a relationship between angle A and the intercepted arc. It's 1/2 dB. So wherever I see angle A in this equation right over here, I'm going to replace it with 1/2 dB. 1/2 of arc dB plus angle D, I'm going to replace with 1/2 AC. Let's do this in our red color. So that's 1/2 arc AC. So it looks like angle 2, so I'm just going to bring this down. Angle 2 is equal to 1/2 dB plus 1/2 AC. If you factor out the 1/2, what you're left with is angle 2 is equal to 1/2 of arc dB plus arc AC. Well, it looks like we have a relationship between the angles that are formed by intersecting chords and the arcs they intercept. In other words, angle 2, which is also equal to angle 1, these two angles are equal to each other because they are vertical angles and vertical angles are equal. These angles, each of these angles is equal to nothing more than 1/2 the sum of the intercepted arcs. Angle 2 is equal to 1/2 of dB, which is the purple guy right over here, which I will underline in purple. That's this arc. And the sum, and the other arc is arc AC, which is this guy right over here, which I will underline in red. So there's our relationship. An angle formed by intersecting chords is equal to 1/2 the sum of the intercepted arcs. So let's take this down in our notes. Put your player on pause if you need to. Take this down in your notes, and then we're going to do a problem together. Okay, let's go to it. An angle formed by intersecting chords is 1/2 the sum of the intercepted arcs. So let's take a look at the question they're asking us to solve. Find the measure of angle x. So what are the two intersecting chords that x intercepts? Well, let's see. I have, what are the two intercepting arcs that x intercepts? So the two intercepting arcs are arc BD, which I will draw in purple, and arc CA, which I will draw in green. These are the two intercepted arcs. So what do we know? We know that angle X, or angle CEA or BED, is equal to the sum of the two intercepted arcs, namely 70 plus 170. So I can say that X is equal to 1/2 of what? Of 70 plus 170. So X is equal to 1/2 of 70 plus 170 is 240. So that means that X is equal to 1/2 of 240, or 120 degrees, and this is your answer. Why don't you try these three problems? They're slightly more challenging, put your player on pause and hit play to resume, and we'll do these together. Okay, let's take a look at the first one. What is the measure of angle x? Well, it looks like angle x is equal to the sum of the two intercepted arcs, and those intercepted arcs are arc AD, which I will outline in purple, and arc CB, which I've outlined in red. Well, that means that angle x is equal to, or x is equal to 1/2 of 80 plus 40, which is equal to 1/2 of 80 plus 40, which is 120. So x is equal to 60 degrees. Okay, let's take a look at the next question. So this is no different than the other. The only difference is that instead of just having measures of arcs, we actually have expressions. But we're going to set this up exactly the same way. So they're telling us what the angle is. The measure of the angle that intersects these two arcs is 53 degrees. So I'm going to set this up as an equation. 53 is equal to 1/2 of what? The sum of 3x plus 3 plus 10x minus 14. Okay, an internal angle, an angle formed by two chords, is equal to 1/2 the sum of the intercepted arcs. So now we're going to combine like terms. So 53 is equal to 1/2 of 3x plus 10x is 13x, and minus 14 plus 11 is minus 14 plus 3 is equal to negative 11. What I'm going to do now to solve this problem is I want to get rid of this fraction, and the way I'm going to do that is I'm going to multiply both sides of my equation by 2. What does that do? Well, that helps get rid of this 2 and this 2, because 2 times 1/2 is equal to 1. So what I'm left with is 2 times 53, which is equal to 106. So 106 is equal to 13x minus 11. When you add 11 to both sides of your, that was awful. When you add 11 to both sides of your equation, let's just put 11 here. When I add 11 to both sides, what I get is 117 is equal to 13x. And when you divide both sides of your equation by 13, you get x is equal to 9. So the solution for this problem is x is equal to 9. Let's take a look at the last problem, which is number 3. Notice how they're not giving you the measure of this intercepted arc, but that's okay. They don't need to give us the measure of this arc. In other words, I can figure out what the measure of arc CB is if I look closely at what's being given to me. Namely, what's being given to me is that AXB is a diameter. It's a diameter. Why? Because it's going through the center of the circle. How do I know this is the center of the circle? Well, that's what the big dot is supposed to denote. That is the center of the circle. I know that a half circle is half 360. The entire circle has 360 degrees. A half circle, or a semicircle, is equal to 180 degrees. 110 degrees is taken up by none other than arc AC. This is 110 degrees. Well, if you subtract 110 from 180 degrees, what you get is 70 degrees. So this arc CB, is 70 degrees. Now I have everything that I need. So x is equal to 1/2 the sum of the intercepted arcs. So that's 1/2 of 70 plus 30. So that means that x is equal to 1/2 of 100, or x is equal to 50 degrees. And there you have it. I hope that helped.